This is A-Level Mathematics, Chapter 13, Vectors, Planes in 3 Dimensions. So, Chapter 13.1.1, find the Cartesian equation of the line through 1, 2, perpendicular to the non-zero vector of L over M. So, first thing I'm going to do is I'm going to take a look at this. So, if it's going to be perpendicular to the non-zero vector of this, so we know that the perpendicular is going to be opposite reciprocal. So opposite reciprocal, so this is in 2D, so this only works when my two dimensionals. So I'm going to take and I'm going to have my 2D, so my M is going to be equal to, so my new M, so this is my slope of my perpendicular. So of my perpendicular is going to be negative M, and that's going to be L, like that. So that's going to be the new one, because this vector right here is this perpendicular, so I should probably put perpendicular instead of slope since we're not doing right there. So perpendicular for this is going to be opposite reciprocals, what I have there. And so now let's go ahead and write out my equation. So I'm going to start off with x. So my x is equal to, so it's going to be through this point, so it's going to be 1, and it's going to be minus m and t for my equation. So if I want to write out the whole thing, it would be, r equals, this point plus t of this point. My y value is going to be 2 plus LT. So now I'm going to go ahead and solve for one of them. So I'm going to use for my x. So I'm going to get t by itself here. So if I get t by itself, I'm going to move that over there. So I'm going to have x minus 1, and then I'm going to divide by negative m, and that's going to be equal to my t. So now I use that one right there. So I'm going to use the x because I'm going to plug it into y equals, so I could have my Cartesian equation out of this. So let's take a look. I'm going to have y equals 2 plus L, and this is going to be where I'm plugging in t for this right here, x minus 1 over negative m. So now if I multiply everything by m, that'll get rid of my fraction, which I have down here. So I'm going to get, let's say negative m, because I have that right there. So I'm going to get negative my equals negative 2m, and this is going to go away. So I'm going to get plus lx as I distribute here, minus l. So let's go ahead and move this over here. I'm going to get negative lx minus my equals negative 2m minus l. So multiply the whole thing by negative 1 to try and clear out that right there. So I'm going to get a lx plus my equals 2m plus l. So that is going to be my Cartesian equation for that vector. 13.2.1, I have to try and pay attention to what I have up here first. Normal is the perpendicular to the plane. So whenever I state that, it's going to be always perpendicular to the plane, and every vector lying in the plane is perpendicular to that normal. So let's say, for instance, this is my pen. This is going to be perpendicular to my plane, which is my paper. So any direction going off of this is going to be perpendicular, because it's going to form 90 degrees with the pen. So that's what that means. Now let's take a look at this one right here. It says find the Cartesian equation of the plane through the point is 1, 2, 3 with a normal of 4, 5, 6. So there is a way of actually writing this out. So it's going to look like this. Start with x, y, z, and it's going to be times 4, 5, 6 is equal to my 1, 2, 3 times my 4, 5, 6. So what it looks like, it should be something like this. It should be r times n is equal to a times n. So times my normal for each one. Okay, so now for this, I'm going to get 4x plus 5y plus 6z is equal to 4 plus 10 plus 18. So 4x plus 5y plus 6z is equal to, this is going to give me 2232. And that's going to be the equation of the plane. (13.2.2) Find the coordinates of the point of intersection of the line r equals 1, 0, 1 plus t quantity 1, 2, negative 3 with the plane 3x plus 2y plus 4z equals 11. So what I'm going to do is I'm going to write this out in my x, y, and z. So if I write out my x, y, and z, so x is equal to, I'm going to get 1 plus 2t, y is equal to t, and z is equal to 1 minus 3t. So now I have my x, y, and z. So what I'm going to do is since this is going to be a point of intersection, I'm going to plug these into here and solve for t. When I solve for t, that's going to give me the time, the t, when these are going to be equal to each other or at the same point. Then I will work it out from there. So I'm going to plug this in. So it's going to be 3 quantity 1 plus 2t plus 2 quantity t plus 4 quantity of 1 minus 3t is equal to 11. I get 3 plus 6t plus 2t plus 4 minus 12t is equal to 11. Combine like terms right here, and I should get 7, and that's going to give me 6, 8. That comes out to be 4t, so negative 4t is equal to 11. So now go ahead and subtract, okay, and solve for t. So I should get t is equal to negative 1. Move that over there, I get a positive 4, divide by negative 4, negative 1. Now I know when it's going to be intersecting each other, but now I need to plug this in over here to actually give me the coordinates of this. So let's take a look. So right here, if I plug in negative 1, my x value would be, so x is equal to, so that'd be negative 2, that's negative 1. Y value, that'd be negative 1. Z value, that's going to give me positive 3, that's going to be a positive 4. So x, y, and z, so my coordinate is going to be negative 1, comma, negative 1, comma, 4. So at that point is when this line right here is going to intersect that plane. (13.2.3) Find if the lines lie in the plane 2x minus y minus z equals 1. So what I'm going to do here is I'm going to actually go ahead and do the same thing I did for the last one, and I'm going to see what I get here. So last time I had a point when they are equal to. Now I'm going to actually try and see if the entire line is in the plane. So let's go ahead. I have x equals 1 plus 4s, y is equal to 2 plus 3s, z is equal to negative 1 plus 5s. So now for that one right there, let's go ahead and plug that into my equation, which is going to be 2 times my 1 plus 4s. Next one is going to be negative, and I get 2 plus 3s, and my next one's going to be a negative again, and it's going to be negative 1 plus 5s equals 1. So let's go ahead and see what we get here. So we should get 2 plus 8s minus 2 minus 3s plus 1 minus 5s, and that's equal to 1. See, negative 8, positive 8. So my s's go away. So now this is going to be really important. My s's go away, and now I have 2, 0, I get 1. So right here I get 1 equals 1. So now if you remember from doing system of equations, when I have the same thing here and here equal on both sides, so it's going to be the same line. So this right here means that all points are on the same line, so this one's going to be yes, and this is actually all points. All points are on the same line, or on the same plane. I'm sorry. All points are going to be on the same plane. Now, so let's take a look here. So let's take a look for this one right here. Do the same thing. I'm going to have x is 3 plus t, y value is 2 plus 2t, z value is negative 3. Now let's go ahead and just plug this in. Same equation, so I'm going to get 2 quantity 3 plus t, and I get minus 2 plus 2t, and again I get minus, and this time it's going to be negative 3 equals 1. 6 plus 2t minus 2 minus 2t. This one's going to be plus 3 equals 1. Right here, t's go away, so that's 0t. So this next part's really important. So now I'm going to have, let me see, 2 here plus 3. That should give me 9. And negative 2, that's going to be 7 equals 1. And now, since it's 7 equals 1, this right here. So if you guys remember, right here, this right here means that it will never intersect. So when I did solve for it and I got a t equals something, that's going to intersect at a point. Because this is 7 equals 1, this is never going to intersect. So if it's never going to intersect a plane, that means it must be parallel. So this one right here means it's going to be parallel. So this is going to be parallel to the plane. So this is never going to intersect that plane. So it's not in there. It's never going to intersect. All points are not on it. Okay, so if I get like this, where I get 1 equals 1, that's going to be all points. So that means that is in the plane. This is parallel, never in the plane. And for my other one that I had right here, where I solve for t, when I get t equals something, that means that I have a point of intersection with the plane. So if you had questions, the practice was 1 through 6. Homework, page 179, 1, 2, 4, 5, and 6.